Hello, today we will be determining properties of quadratic equations, or commonly known as parabolas, and how to graph them. So parabola fits very mathematical descriptions, so if you hear that word, then you can just think of that as a type of quadratic equation. Let's refresh ourselves on what a quadratic equation is. You have y equals ax squared plus bx plus c. So we know it's a quadratic equation because we have the power of 2, and that's a standard form of a quadratic equation. If b and c are equal to 0, then we're left with y equals ax squared. And in this case, we know that the parabola has a vertex at the origin, which is 0, 0. And because we know a is positive and not negative, we know that it goes upward in both directions. However, if b is equal to 0, but c is not equal to 0, then we're left with y equals ax squared plus c. In this case, your vertex would be equal to 0c on the y-axis. Now that we have refreshed ourselves on the quadratic equation and some of its properties, let's take a look at the standard equation for a parabola with a vertical axis. And this can be done by essentially completing the square. If you complete the square of our standard quadratic equation, you're going to be left with the standard equation for a parabola, which is stating that y equals a x minus h squared plus k. If you're not familiar with completing the square, I will link a video in the description below detailing the specifics on how to complete the square. In this case, rather than b equaling 0, h and k will actually give you the vertex of the parabola. And then again, a being positive or negative will tell us if the parabola is going in the positive direction or the negative direction. Before we go into a few examples with the equation for parabola, I'd like to note that if you were given the quadratic equation and you're not given the standard equation and you're asked to find the vertex, there's a cool and easy trick that you can use that kind of represents the quadratic formula. If you're not familiar with that, I will also link that below in the description. However, you can use the opposite of b over 2a to find the x-coordinate of your vertex. So that's going to be here. And then what you do is plug this value in to the equation here, and that's going to give you your y-coordinate. And that's how you're going to solve for the vertex. Again, if you are given a quadratic equation and you're asked to find the vertex, rather than completing the square, finding h and k, you can do this cool little trick with the theorem for locating the vertex of a parabola by just taking the opposite of b over 2a, plugging that into your quadratic equation, and then finding that y value. Okay, let's take a look at a couple examples. Okay, looking at our first example, we are going to do two different things with this one. We are going to look at this equation that we have, and we're going to find the vertex using the formula for locating a vertex in a parabola. And then what we're going to do is find the standard equation for a parabola and then find the vertex. And I'm going to show you that you can do it in either way. However, one way might be easier depending on what the question's asking. Looking at the theorem for finding the vertex of the parabola, we know we have the standard quadratic equation right here. What we can do is we take the opposite of b over 2a. This is going to be equal to our x value. And then once we find this x value, we plug that in and we can find the y value. So in this equation, we know that a is equal to -1. We know b is equal to -2, and we know c is equal to 8 because we have our standard equation. ax squared plus bx plus c. And so what we want to do, solve this equation, the opposite of b, so we get the opposite of negative 2, which gives us 2 over 2 multiplied by a, which in this case is negative 1, and then we get 2 over negative 2, which is equal to negative 1, which is equal to our x value. Now that we understand our x value, we just plug this value in to this equation so we can solve for our y. We have y equals, x in this case is negative 1, so we have a negative 1 squared minus 2 times a negative 1, and we have 8. We simplify this, we get y equals negative 1 squared is equal to 1, and we do minus a negative 2, so that's plus 2 plus 8. Y equals negative 1 plus 2 plus 8, and we are left with 9. And so this is our y value. Therefore, we know that the vertex is equal to our x value, which is negative 1 and 9. And this is our answer. Again, we didn't have to do much computation. By using the theorem for locating a vertex of a parabola, we were able to very easily solve for x, use that x value to solve for y, and we know that this vertex is again at negative 1, 9. So if we were to do a quick simple graph, that would put us negative 1, 9. That would make that the vertex is here. We know that a is negative 1, so we know that this is going to be a downward parabola or quadratic equation. If you wanted to factor and actually solve for your values of x's when they intercept with the x-intercept, you can use the various methods of factoring that I've talked about, and I'll also link those below in the description. So you have completing the square, you have factoring, or you have the quadratic formula. So any 3 of those variations will give you a value of where they actually intersect at the x-axis. So that can give you a more holistic picture of this graph. We're just looking to understand some basic concepts, so the vertex or opening up or opening down. Okay, let's look at this exact same example, but let's do it with completing the square and then using that h and k value to find the vertex. Okay, we're going to look at the exact same problem, y equals negative x squared minus 2x plus 8. But this time, instead of using the theorem for vertex of a parabola, what we're going to do is look at completing the square and finding the standard equation for a parabola. And to do that, again, the standard equation for the parabola is y equals ax minus h squared plus k. So this is what we're trying to get to from where we are right now. What we need to do, again, is complete the square. I would urge you, if you're not familiar with how to complete the square, to please check out that video and then return to this video so you understand. I will go a little faster since I've already described how to do it once. Once you look at that video, you will be able to understand exactly what I'm doing and why I'm doing it. What we're going to need to do is get the x values by themselves to complete that square, add to the left side what we've added to the right side. So that's what we're going to do. First step is we need to get x squared to be by itself and not have any value that's greater than 1. And so we're going to factor out that negative 1. So we're going to get y equals, factor out the negative 1, which is going to leave us x squared. And we're going to factor out the negative 1 from the 2. It's going to leave us with a positive 2x. We have some arbitrary value, and then we are left with the 8 out in front because we haven't touched that. Now what we want to do is do a simple factoring. What value here is going to give us this value when multiplied by itself and then add it together. We know that 1 plus 1 is equal to 2, so therefore we know that this value here is going to be 1. And we can just check that real quick because we have x plus 1, x plus 1. We get x squared plus 2x plus 1, which is exactly what we're going to get there. So we will add that 1 value here. Now what we must remember is that 1 value is actually a negative 1 because we can't forget about this value that's out in front. So we've added a negative 1 to the right hand side. So we also must add a negative 1 to the left hand side. So this is going to give us a negative 1 plus y, which is then equal to a negative 1. And then we have our factor term, which is going to be x plus 1 squared. And then we have 8 here on this other side. Okay, now what we want to do is set y by itself because we're trying to get to this form right here. So to get y by itself, we just need to add 1 to the other side. So we get y equals, we have our negative 1, x plus 1 squared, and we have plus 9 because 8 plus 1 is equal to 9. Now we have a form that is similar to this equation which we were trying to get. We see that in this case, a is equal to a negative 1. We have h, which is equal to a negative 1 because it's a positive 1 and h is negative. So this is a negative 1k, in this case, is equal to 9. Vertex is equal to hk, and in this case, equal to a negative 1, 9. And this is exactly what we got when we did it with the theorem for the vertex of a parabola. See, there was a little bit more steps involved. However, if the equation does ask you to find the standard equation for a parabola and then find the vertex, you'll need to go through these steps to get your answer. All right, let's look at another example. Okay, looking at our next example, we have a vertex at 4, negative 1, and it passes through the point 0, 1. The question is to find the standard equation of a parabola that has these parameters. What we're trying to find is the standard equation for a parabola, which we know is y equals ax minus h squared plus k. Well, because we're given the vertex, we know h and we know k, and we also know that it passes through the point 0, 1. So in this case, we also know y and we know x. All we need to do is find a and then plug that value back in to find the standard equation. Okay, so let's get started. We have y equals a and we have x. We have h, which is 4 squared plus, and we have k, which is negative 1. We also know we have y, this is 1, and we have x, which is 0, so we're going to get equals a multiplied by 0 minus 4 squared plus, and then we have a negative 1. All right, we're simplifying. We get 1 equals a times negative 4 squared minus 1. Negative 4 times negative 4 is 16, so we get 1 equals 16a minus 1. We're going to move this one over to the other side, so we get 2 equals 16a, and now we're going to solve for a, and we get 2 over 16 equals a, which is equal to 1/8. And so that was the only variable that we needed. Now all we need to do is plug in a, and we have h and k, and we will have our final answer. Y equals, we just found a, which is 1/8. We have x minus h, which is 4, squared minus k, which is 1. And this is our final answer. Okay, and what does this tell us? Again, this tells us that our vertex is at 4, negative 1. So it's here. We know that it's positive because your a value is not negative. So we know that we're going up this way and we're going up this way. We can also, if we wanted to, if the problem asked us to find our x-intercepts, and we can do that by either factoring, completing the square, or using the quadratic formula. And there you go. Now you know how to find the vertex of a quadratic and or a parabola and the direction that the graph will go. This information will help you pinpoint or specify information without solving a full equation. You can do any of the strategies that we talked about today, cutting down a lot of time. So if you have any questions or comments, please leave them below. If you learned something, please like and subscribe, and we'll see you next time.